right, today we are going to be discussing on how to calculate the standard deviation and the variance with a formula you probably don't know. The formula is called the raw square formula, and this is it. This is it. Standard deviation is always equal to the square root of summation of s square minus summation s then square over n, everything over n. What are we trying to say here? Let's try to understand what this formula is actually saying. The summation s squared that you have here is telling you that you are going to square each of the data. After squaring each of the data set, then find the sum. That's exactly what this is all about. The summation s squared is telling you that you sum all the data set, then you square. Please notice the difference. Here, you square all the data set, then you find the sum. Here, you sum all the data set, then you square. So after doing that, then you can simplify the value. Let's take a look at the example so that you can understand what you are trying to say here. So this is an example. For your sake, we should calculate the standard deviation of the weight of 5 students shows below. We have 21, 25, 24, 30, 34. Now let's see how I'm going to deal with that. I will draw a table. This is all my data which I have. I represent it as X. Then I will square each of the data sets. 21 squared is 441. 25 squared is 625. So I square all and I get this. Now the summation of everything here, which is all data set, is 134. The summation of their squared is 3698. So these are going to simplify into the formula which I have written earlier. So let's see how I simplify that. The summation of s squared is the sum of everything here. So, and I get 3698. The summation of s inside this bracket is this, which is 134. So I simplified it here. Then I can definitely get this thing now. 369,134 squared over 5. I simplify. Subtract this thing from this, divided by 5, you get 21.36. You can actually pause this video and use calculator to show that this thing is actually true if you are half a doubt. Now let's see. The square root of this thing gives us 4.62. So assuming you are asked to calculate the variance, then you would have stopped here. 21.36 would have been your answer. You won't need to find the square root. But since we are calculating the standard deviation, we get 4.62. And the question is a little. You can see this method look a little faster, unlike the one I used in my last video, if you have watched that. Now you can also use this if you like. And that is using normal formula that you are used to by finding the deviation itself. You can see here, I will show you that 21, 25, 24, 30, 34. If you sum all this data and find divided by 5, you know, actually, if you want to use normal method you are used to, you have to find the mean. So if you sum all this data divided by 5, you get 26.8. And 26.8 is now your mean. You subtract each of the mean from all of this, then you get 21 minus 26.8, you get this. This minus 26.8, you get this. So if you sum everything together, you are going to get 0. Remember what we are doing here is deviation. We are calculating the deviation. And remember, one simple way to test if you are making a mistake is to sum all the deviation. It must give you 0. And that is what I have done here. Now finding their square. You square everything here, you get this. Square this, you get this. Square this, you get this. Then everything you get 106.8. Now you can find your standard, you can find your variance or standard deviation by finding the sum of everything here divided by this number of data, which is 5. So we have 106.8 divided by 5, and that will give you 21.36. So 21.36 here is your variance. And finding their square root will give you the standard deviation, which is 4.62. You can now check and compare it to what I have here to realize that the answer is the same thing. So that's what I actually wanted to show you here, that either you use the first formula or you use the raw method, you will still get the same answer. So that is very simple logic way to calculate the standard deviation and variance. Now let's talk about transformation, because actually question will ask you something on this. Transformation is when you have a data set and you are transforming them into another data set. For example, data set we have here, which is 21, 25, 24, that is 34. You can decide to transform them by addition, subtraction, multiplication, or division. You can transform them using any method you like. So if you are transforming them by addition, You can probably decide to add 5 to everything here. You have 26, 30, 29, 35, 39. That means that will be your new data. That's what we mean by transforming. So there is an easy way to know what your variance will be and standard deviation will be if you are transforming your data. And this is the principle you need to know. You can try to pause this video and jot this down. When you are adding or subtracting with constant, I mean, when you are subtracting a constant from all your data sets, or you are adding a constant to all your data sets, just know that your distribution will not change at all. I mean, the variance and the standard deviation will still remain the same. This is what we are trying to say. What we are saying is that if you add any number to all these data sets, for example, instead of having a data set of 21, 25, 24, 30, 34, you can decide to add 10 to all these data sets and add 31, 35, 34, 30, 40, 44. If you try to find the standard deviation and the variance of this data set I just mentioned, you will still realize that it is the same thing as what we have calculated here. You will still get 4.62 and 21.36. So meaning is that whatever you added to all the data set to transform your data, it does not change the standard deviation or the variance. Even if you subtract some value from each of the data set, you still get the same answer. That is what the first principle is telling you here. So concerning the multiplication and division, this changed our data set, our variance and standard deviation. If you are multiplying, the same thing will be applicable to standard deviation. Let's say you are multiplying by 2. For example, instead of having all the data set to be 21, 25, 24, you could have transformed it to 42, 50, 48. You can see I'm multiplying by 2. So if I try to calculate the standard deviation and variance for that new data, what I will discover is that the standard deviation will be 2 times the standard deviation which I have earlier. So when you are multiplying your data sets, you are going to get the same multiple of standard deviation. And now you can now square it and you are going to get your variance. Just note that the variance will not be exactly the same. For example, if you are multiplying by 2, your new variance will be 4 times the previous variance because of the fact that you are going to square it. If you are multiplying by 3, your new variance is going to be multiplied by 9. I mean, it will be 9 times the previous variance because 3 squared will give us 9. But if you are considering standard deviation, the standard deviation will be 3 times the previous standard deviation. So whatever you use to multiply, just know it's going to reflect on the new standard deviation and the new variance. That's just it. And if you are using divide, the same thing goes with division. You are going to get your result to be divide. Assuming you are dividing all the data sets by 3, that means your new standard deviation will be the previous standard deviation divided by 3. And your new variance will be the previous variance divided by 9. Please get the logic between standard deviation and variance. For standard deviation, we multiply straight or divide straight. But for variance, we squared before we said we make our conclusion. And how about the mean? If you are transforming, does it affecting the mean also? Yes, it affects the mean. If you add by constant or you subtract by constant, it affects the mean by addition and subtraction too. For example, if you are adding 10 to all the data sets, your mean will be increasing by 10. If you are subtracting 10 for data set, your mean is going to be decreasing by 10. So if your mean happened to be 20 before, it will change to 10 if you are subtracting 10 from all the data sets. If you are adding 10 to all the data sets, that means your mean is going to be 30. That is 20 plus 10. So that means addition and subtraction of constant from all the data sets, we shift our mean. It will increase it or decrease it. The same thing applicable if you are multiplying or dividing. Your mean will also be divided or multiplied. So just get the logic. The question may ask you that if all the data set is being multiplied, or let me say by 2, or they might say if all the data set has been doubled, what will be the mean? Just know that the mean also will be doubled. If all the data set is tripled, the mean also will be tripled. If 5 is added to all the data sets, the mean also will be increasing by 5. That is what we are trying to say. For standard deviation, the 5 is the case. If you are adding, then the standard deviation will still remain the same. If you are adding, the variance to remain the same. If you are subtracting, the variance to still remain the same. If you are subtracting, the standard deviation still remains the same. But if you are multiplying, let's say you double all your data sets, just know that your standard deviation will be doubled. So while your variance will be 4 times. Get the difference? If you have tripled all your data sets, just know that your standard deviation also will be tripled, while your variance will be 9 times as much as the previous. I hope you get that perfectly. So that is that about transformation. So we are able to deal with that. I think you should not have any problem concerning that. You can quickly take a look at these two, please. Coefficient of variation. How do we take a look at coefficient of variation? It's quite easy. Just know the formula for it. To calculate a variance coefficient of variation, just find the standard deviation, then divided by the mean, then multiply by 100. That is the answer for coefficient of variation. You don't need to learn much example on that. Just know the formula. But I will show you how this thing works. For example, let's say we have the average price of a certain thing to be $50. That is the mean. And the standard deviation happens to be 5. To calculate the coefficient of variation, we say 50 divided by 5. So that's a simple way, they multiply by 100. We are going to get 10%. So we say 10% is the coefficient of variation in this case. Another example is, let's say we have the mean to be 100 and the standard deviation to be 5. We say the coefficient of variation is 100 divided by 5. And that will give us 5% when we multiply by 100. So that's how to calculate coefficient of variation. I don't think anything is hard concerning that. Just get your standard deviation, then the mean, divide it, and multiply by 100. Most of the time, the answer is always left in percentage. And sometimes that might not put in a percentage, you will always get the answer. You know that 10% is always the same thing as 0.1, and 5% is the same thing as 0.05. So, but most of the time, it is always nice to leave your answer in percentage if you are calculating the coefficient of variation. So I hope you learn from this tutorial. So that is that about standard deviation, coefficient of variation, variance. I will be seeing you in the next class. Please consider to subscribe and comment in the comment section below. So let me know, understand how you enjoy this video, and if you have any question, you can please drop. I will reply to your answer, or you can even try to chat me private if you have any question that is bothering you or any doubts concerning what we have learned so far. Thank you for watching my video. Bye.